Yes, good. So, good afternoon, everyone. I am going to be very light. It's okay. I'm going to be very light today because I'm the last one, so I will not keep you for long. Thank you for having me. My name is Emily. I am a research engineer based in Clermont-Ferrand. And I'm going to talk to you about time domain in the context of optical astronomy, more specifically with the Zwick Transient Facility and the Rubin telescope. So I will focus on the activities of the Think broker and how we deal with the alert stream in that context. The Think it started as a French project, but now it's an international thing. We have almost 70 researchers for 13 different countries that are working on the project right now. It's led by myself, Anaïs, who is in Australia, and Julien Peloton, who's in IJC Lab. So keep in mind that during this talk, I will say a lot, we or I did this or that. Whenever I say that, what I really mean is that I had an infinite number of Zoom calls with amazing people who actually did the job. So this is what you should keep in mind. So that is the disclaimer. So what we are going to do here is I'm going to talk really briefly. And as I told to you before, I am from optical astronomy. So this is a little bit out of my league, but I hope this will be meaningful to you. I'll explain a little bit about the Rubin broker ecosystem, how machine learning is actually not optional at this point, and what do the human has to do with all that. So just so we are all on the same scale, on the same page when I talk about big data. These numbers are probably wrong, okay? I just wanted you to have an idea of the order of magnitude of how these data sets grew up in optical astronomy. So we had this low one, which around 100 terabytes, the entire data set. We are now working with ZTF. So this is currently in operation, and it generates around 1.4 terabytes per night. And for the purpose of alert 300,000 alerts per night. Rubin is expected to start on 2025 and is expected to generate 15 terabytes per night every for 10 years minimum. So you see that from here to here to here is a non-negligible order of magnitude increase on these data sets. So we will have to adapt. As I said, everything that I show you that has been done today is with ZTF, so it's with this telescope, but we were promised, and I was not the one who made that promise, but we were promised that all of the data formats and communication protocols that has been used for ZTF will be very similar to the process that we will have for LSST. So we are actually, not only our team, but a lot of teams around the world, we are using ZTF as a test bench for Rubin, actually. This is what we're doing here. So the Vera Rubin Observatory Large Survey of Space and Time, for lack of a smaller name, is being constructed right now in Chile, so very close to La Serena. It's an 8.4 meter telescope, 3.2 gigapixel camera, and it will detect around 10 million new possible candidates transients per night. So what do I want you to keep in mind with all this? First, very big data. Second, survey mode of observation, meaning LSST is not a telescope that you point somewhere. It has a predefined path around the sky, a predefined survey strategy, and it's going to record everything that passes in front of it, and it's your job to find whatever you want in the data set after that. Okay, so the task that we have now, you have to understand, is how we are going to take this huge amount of data that was taken outside of your control, someone else decided that, and distribute the correct data to the people that actually want to do it. So this is more or less the path that the data has. So it's a difference imaging analysis pipeline. You take a picture, you come back to the same point of the sky, take a picture again, you do this minus that, and if there is any signal higher than a few sigma, you say, ha, there is something new here. So the telescope is expected to generate around 10 million of these things per night. And with ZTF today is like 300,000 or something, between 200 and 300,000 per night. This goes to a broker. And it's the task of the broker to do whatever is necessary, machine learning, catalog classification, cross-match with another streams, anything, to make this huge thing become smaller and redirect to the specific communities the correct subset of data so they can do their science. Keep in mind that if this person is an exoplanet person and that person is a supernova person, they want very different things. And it's the goal of the broker to do that. Nowadays, with ZTF, there is no big, huge implementational problem on directing the stream to whoever wants to receive it, basically. There's just politics. With LSST, there is a problem. There is no internet bandwidth from Chile enough to send copy of the stream for everyone who wants it. So in 2021, they made a competition, a worldwide competition. So a lot of groups around the world made an application saying, I want to receive the raw stream from the telescope. So these seven groups were selected. So we have Babamu Antares and Pete Google in the US, Alerce in Chile, and in Europe we have Laser in the UK, Ampel in Germany, and Think, which was originally in France. So these seven groups are the ones who are going to receive the raw stream from the telescope, and it's their job to pass the data to the people that want to do something. So what is, when I say an alert, what is an alert? So every time that the difference image analysis detects something, they produce a small data package. A small data package contains 3 postage stamps. This is very small images, 60 by 60, I think, pixels. And you have here the science image, which is the image you took today, the template image, which is the one you compared with, and the difference, which is one minus the other. These 3 images plus the photometric history of that point on that point on the telescope. So today is always the last point on this light curve. With ZTF, inside the alert stream, we receive 30 days of data, up to 30 days in the past, if the data exists. With LSST, they promise we will have a year inside the alert stream. And any other metadata that is available for the telescope position, and any other thing that they might have at the moment. So how this goes to people. So this part here on top is the same thing that I told you before, but instead of being round, is in a straight line format. So this is the broker. How do we do my science with this now? So this is you. Below this red line is where the expert should work. So you go there. You have a website where you can download the data so you can have an idea of how the data look like. And once you understood what you want, you can do 3 things. You can construct a filter or a catalog cross-match or a tailored science module. I'm going to talk a little bit about the 3 of them. The first 2 is basically very simple questions that you want to make to the stream. So for example, you can say, I want everything with magnitude less than blah. Or I want everything in this specific square of right ascension and declination position in the sky. Or you can do cross-match with things. With existing catalogs, you can cross-match with streams from other wavelengths. We have been talking that is already available. Or if you are a gravitational wave person, for example, you can cross-match probability maps. If you have your probability map of the sky, you can upload and get all of the alerts from ZTF at the moment, LSST the future, that have a probability higher than blah in your map. Having been listening to you talking for the last 2 days, I got really scared because in my mind, this cross-match thing was not so complicated. So I will be very honest here and say that by this cross-match, I mean, you have your catalog. At this point, inside the broker now, we cross-match with Simba, the NTNS, and a few other catalogs. If you have your own catalog, you have to provide position and a radius, and we don't make questions. And I don't know if that's right, but that's what it's done. I'll be happy to know if you have other thoughts about that. But for example, I was talking about probability maps. If you have probability map, what you can do, there is a tutorial to show you how to, it's a very small piece of code that you can get, and then you need to have your credibility level. So you have to say, give me all the alerts in the probability region higher than 80%, for example, and then you will be able to do things like this, where you have your probability map, and overlap, you have the ZTF alerts that coincide with that region of the space, for example. And the other thing that you can do is you can do a science module. A science module is a Python function, basically, that inputs an alert and outputs or a Boolean, yes or no, or a score. And then you can say, give me everything that is or true, or with score higher than, and then you give a number. It's you who does the threshold. Normally, a science module can be as complicated as you want. In Think, we have a lot of science modules that are based on machine learning models. So this is the normal way to do it. So you take the data, you have a train and a test set, and you train your machine learning model. You optimize this until you are happy or your deadline arrives. Normally, those two things happen at the same time. And then when that happens, you have a trained model, you take whatever extra information you need, you upload that to the broker, and then the broker will on the fly filter the stream and direct that to you, basically. One of the examples that you can do this, for example, we have been talking with Irwan and Miguel about finding early TDs. So I am not going to get into the details of this because this is ongoing work. I'm supposed to come back here in a few months so we can finish this. But the idea is you want to find something like this. You want to find TDs that are actually on the rise. You have some tailored feature extraction module in using Rainbow in many different bands, and then you can find a parameter space that allows your machine learning model to work. Once you have this parameter space, then the rest is normal machine learning techniques. But then, okay, you did all that. So you construct your model, how you are going to receive these things. If you need a reply in the middle of the night, meaning you want to receive your candidates in the middle of the night, the only thing you can do is a Kafka stream. So if you want to be able to be notified in the middle of the night, you will have a Kafka stream that will deliver to your hard drive all of the alerts that survive your selection cut. This can be done. If you can wait until the end of the night, then you have other ways of communicating. So for example, then you can have a bot. This is an example of our Kilanova Slack bot for Kilanova. We have a few bots on the Think Slack. So every night, the data is processed, is passed through the filter, and everything with higher than 50% probability, or everything that cross-matches something that you want, for example, will generate a Slack message. And here in this message, this was tailored for the grandma people because this bot is for them. So they decided that they wanted this information there, but you can, grandma is a network of robotic telescopes around, so you can do whatever you want. You can put whatever information you want in that. And then you will be notified by like that. The other option is if you made a science module that gives a score. So for each stream, for each alert, you generate probability number. That number can be added to the broker as an additional column, and that will be stored with all of the other columns that we have. And then you can come to this web page, which is our download service, and you can put, I want my score higher than blah, and then you will download everything that you need to download from your science module. So there are many ways that you can access this information. Everything I have been saying to you up to now is how do you classify and 5 things that you already know that is there. That is not the most interesting thing we do. Okay, I really like this quote from Norris 2017 that says that telescopes that merely achieve their expected science goals has probably failed. Because you are taking the better camera that has ever been constructed, pointing to somewhere where nobody has ever looked at. You have to find something new. There is some new science to find in that. And the question is, in this, with so many data and in all of this new infrastructure that you have, how do you find those stuff? So we have, there is 2 different challenges when you think about that. There is the actual challenge of practical of how do we find these things. And for this, we use some very simple machine learning model based on isolation forest. And the second part, which I think it's the most difficult, is the sociological issue. Because once I have a candidate that I think is nice, I need extra information. I need people to do follow-up. I need someone who can write a paper, who can tell me if I'm doing something right or not. So this is the first night that we ran. It was 25 January last year. That we run the anomaly detection module in Think. This was the first high anomaly score object that we found. I am not a variable star person, but apparently this means something. Anyway, they were excited about this. I don't understand, and I am not gonna talk too much. But the point is, we were able to get within like 1 or 2 nights, we were able to get to activate different parts of the community to get observations on salt, on South Africa, in Russia, in Spain, in Italy. And this was a very good exercise of how we can coordinate these communities in order to reply to something that we found was interesting. This was just the first exercise, but this gave us an idea that it is super important to have a connection with the community that is actually going to do those follow-up observations. But then there comes the issues. What is an interesting anomaly? When you take an anomaly detection module and you pass through the broker data, 70% of the time it will give you a glitch on the CCD, something that passed in front of the telescope, an asteroid, something that 70% of the time is not something interesting, right? On the 30% of the time, there is something astrophysical, depends on who is looking at it. So in order to try to, how do you, there is the concept in machine learning of active learning, active in the sense that you don't provide the training set, you let the machine decide what the training set is going to be. You can also use that for a very normal anomaly detection model, very bad. Then I go through 1 night of data, I get the object with highest anomaly score, and I show it to one person. And then you ask this person, are you interested on this? Yes or no? If that person said they are interested on that, nothing changes because, okay, the model is correct. If that person says, I don't want to see this, you go back to the model and you downgrade the parameters that led you to that decision. So next time, it's less likely that that person will be able to see the same kind of anomaly again. And if you do this in parallel with different users, you can have one personalized anomaly detection model for each user that is using the broker. And this is what we are implementing right now. How we are going to, the point is how these people are going to interact and how they are going to say that this is good or not. Remember that I told you that we have bots, right? I show you a Slack bot. It can be a Slack, it can be Telegram, it can be whatever you want. This is Telegram. For some reason, Telegram is easy to implement for what people who actually do this stuff told me. So the Telegram bot for the anomaly module that we have, you can scan this QR code and get in there yourself. It will show you something like this. So it will show you the postage stamps, the light curve, and some information that people wanted to know, right? And then at this point, and then what do we want? It is Telegram. So you can go there and you can do thumbs up, thumbs down, right? And then this thing, in the end of the night, these reactions I read by the code, which automatically retrains the model and update for the next night according to your definition of what is an anomaly. At this point, if you go to this QR code, it's not personalized, meaning there is, I think now 15 or 20 people in this channel. So we just do a statistical count of the ups and down votes. But what we are working on, and it's, we started with a small group of people just for the first round, is to have like 3 different people doing this in parallel and answering yes to different types of anomalies. In the future, we will be able, our goal is to have for each individual users, you will have your own Telegram channel that no other person will have access to. And then the model will be in parallel trained for only what you think it's an interesting anomaly. And in order to finish, what is the point of all this? What I want you to keep in mind is that in this context, if you want to do science out of it, big data only means that you have to filter a lot, because the person who is going to interpret that data, make a discovery and write a paper about it is still a human who cannot deal with more than 10 and 20 objects at the same time, right? So this means that our algorithms needs to be absurdly personalized for what each science expert wants to do. And in order for that to happen, the people who are the software developers, who not necessarily are astronomers, need to have face-to-face conversation with the astronomer who does not know how to write one line on C++ code. These two people need to trust each other, because when you are developing pipelines that are personalized, this conversation from the beginning of the development of the pipeline is absurdly important. So what we have been doing in Think from the start is have small local meetings. So these are not more than 20 people, 30 people at the same time. We had a couple in France. We have one in Switzerland. Last May, we had one in Australia. And this May, we are going to Rio, which as a Brazilian, I would be super happy to show you around. And the idea in all of those meetings is to get the developers close to the astronomers who are using the data, talk to them in a very friendly environment so they can understand what everyone wants from the pipeline. By now, you should understand that we are not aiming to 1 million users. We are aiming to a few users who know exactly what they want and will be able to spread the word and help others to get real science out of the data. Just to finish, how do you do that? So and then you have a sociological problem. How do you inspire people to work in that kind of environment, which, believe me, requires a lot of patience. So in the beginning of each Think meeting, we have what we call Think Dream Shots. So suppose that you have power over the LSST data. You are God, you can do anything you want. What do you want to find? And we ask them to write in pieces of paper. This, in the end, begins our walls of Think Dream Shots. You need to be minimally realistic, right? So this is from Australia 2023. Finding a Dyson sphere or a white hole, yeah, why not? If it's there, we're going to find it. Wishing astronomers to use real units, that's too far-fetched. Right? So that's not going to happen. I'm sorry. So this person realized that this was not going to happen, and then he or she just changed what the dream. But my point is, my point is, we have enough infrastructure right now to find the things that we already know we are going to find. What we need to think is, what are the weird things that we want to find? So I also invite you to think, if you had power over the data that is coming, not only LSST, but whatever data that you know are coming your way, be very bold, because this should be the beginning of the development of the pipeline. This very weird thing that I want to find should guide how you develop things. And once you know, be very specific about what you want, and then just tell us, what do you want to see? Thank you very much.
Questions? Did you?
Very interesting. Thank you. How do you account for the fact that when you see a lot of thumbs down, it's harder to put your thumb up?
Yes, we will have, okay, so there was not too many thought on that. The way it works right now is we have one channel only that is going to be public. We call that citizen science. We didn't have a better name for it. So what it means is, if you had 20 thumbs down and 19 thumbs up, it's going to count only one. It's just going to do a mean count, and that's it. There is no further thought on that. In the personalized case, only you are going to have access to your Telegram chat. So there is going to be only you, and you can change your mind. I'm pretty sure about that. We have requests, and we are trying to, this is a real request actually, that we are trying to understand how to make possible the user to go back in the history and change their mind about the reactions that they did. It seems simple, but implementation in that is very difficult. So I'm not promising anything on that respect. I'm just saying that we know that is a request, but that's it.
Okay, thanks.
Anybody online?
Yes, Jean Ballet. I was wondering whether all brokers offer the same services exactly, or are they all different, and can one address all of them?
Yeah, so that's a question that it's a very good question actually. So the brokers are completely independent in the sense that the only thing that we receive from the project is that the task of the broker is to receive the alert from the telescope and pass that through to the community. In practice, all of them have some kind of classification based on almost all of them have some kind of classification based on machine learning or cross-match or filtering. So if you have a very simple question, so if what you want to do is super simple, like just a cut or just something trivial, probably all of the brokers will do the job for you. That's not a problem. Once you start having more complicated questions, then it becomes a matter of interface. Each broker has a different back end. So even if the front end of the brokers might seem similar, the back end is very different from different brokers. So then it depends, when you have very difficult questions to answer, then it's where they become different from each other.
Phil.
Hi, this is Phil Evans. So you have these classifiers at the moment to say, hey, this looks like a supernova, this looks like a TDE, kilonova, whatever. I'm not a gambling man, but I would be able to bet a fair amount that after a couple of years of LSST, what we thought we knew about supernovae, TDEs, blah, 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 we're going to realize we knew nothing.
Yeah.
And so I'm wondering, some of this could be contentious. You know, at what point do you decide to change my thing that classifies as TDEs because we now know, stroke believe that TDEs look different? Is there a plan, a program, a thought? I mean, obviously individuals can presumably do it with their customized things, but at what point will the main think team, how responsive are you going to be to changes in science that will feed back into your classifiers, if you see what I mean?
Yes. So there are two parts of your question. The first part is what Julian is the main developer, what he likes to say is that processing a centralized, development is distributed. So Think has nowadays, I think, 15 or 18 different science modules. Each science module is developed by a different science team, and they are completely responsible for whatever they do. On the Think side, from the beginning, the idea of using Think was because we wanted to implement the active learn loop on the fly, meaning that you have a classifier. I'm a supernova person, sorry, so my examples are supernova. So you have a supernova classifier, you classify your data from the night, and then from that night, the algorithm tells you which object you do not have a label for, but it would be helpful if you did. You have a wish list. This wish list goes to some public forum, some target of observation management or something like that. Once a classification is posted on some public forum, for example, the transient name server or something like this, you have an automatic Kafka stream that directs the label to the trained sample, retrain the model, and update the model to the breaker without me having to touch on it. And this is the part that I most dream of. So all of this should be automatic and should be logged. So we are going to, for this summer, we made the first round with actually telescope time that we have in Australia to understand how much of these we are able to do at a time. Realistically, thinking depends a lot on how much the labels are provided. But if the learning loop is running the way we should, I would say something around once a month or something like that. for starters, I would say that, but that can change, obviously.
So one more question. If not, there will be another chance, but first let's
Thank you.
thank Emily again.